In this lecture, we'll discuss managing the system implementation. Companies are intensely concerned with the quality of their products and services. The main objective of quality assurance is to avoid problems or to identify them as soon as possible. Poor quality can result from inaccurate requirements, design problems, coding errors, faulty documentation, and ineffective testing. In system engineering, a software development process that stresses solid design, accurate documentation, and careful testing. In the SEI, or the Software Engineering Institute at Carnegie Mellon University, it designed a software development standard used successfully by thousands of organizations around the globe. The Capability Maturity Model, or CMM, improves software quality, reduces development time, and cut costs. The new model integrates software and system development into a much larger framework called Process Improvement, or CMMI, the Capability Maturity Model Integration. CMMI tracks organization progress using 5 maturity levels, from level 1, which is referred to as unpredictable, poorly controlled, to reactive, to level 5, in which the optimal result is process improvement. ISO, or International Organization for Standards, is a worldwide body that establishes quality standards for products and services. ISO standards include everything from internationally recognized symbols to the ISBN numbering system that identifies this textbook that we are currently using for the course. Application development is the process of constructing the program and code modules that serve as the building blocks of the information system. Structured analysis, object-oriented analysis, and agile methods are 3 popular development options. The objective is to translate the design into program and code modules that will function properly. You want to review the system design, requirements modeling, functional disposition design, structured data and process modeling, data flow diagrams, case diagrams, class diagrams, sequence diagrams, state transition diagram, activity diagram, development methodology, user interface, entity relationship diagrams, and the overall system architecture. When you're looking at an application development task, you look at traditional method is to develop an overall strategy, design, code, and test and document individual modules. A module consists of related program code organized in small units that are easily understood and maintained. Agile method creates a system through an iterative process of planning, designing, coding, and testing. An example includes a spiral model and the extreme programming model. In Figure 11.7 is a simplified model of an extreme programming project. Note the emphasis on the iterative and the testing. System development tools will be the entity relationship diagram. It shows the interaction among system entities and objects. Flowchart is the logical rules and interactions graphically using a series of symbols connected by arrows. And pseudocode is a combination of English and computer code. You also have decision tables and decision trees used to model business logic for the information system. Project management, structured development techniques, and tools are used along with object-oriented and agile methods. In this case, it shows you a sample of a decision tree that reflects a salesperson promotion policy. Like a decision table, decision tree shows the actions to be taken based on conditions. In the figure, it shows a preferred customer. The customer is yes if the person has an order of more than $1,000. If the person also uses their credit card, they are a preferred customer, and therefore that person will receive a discount of 5% and an additional 5% discount. If the person has orders more than 1,000 but does not use their credit card, they will get a 25% bonus coupon. Other tools used are structured charts, and they show the program modules and the relationship among them. Characteristics of object-oriented application development is individual object instances belong to classes of objects with similar characteristics. The relationship and interaction among classes are described using a class diagram. Class diagrams describe the characteristics of objects in the class and the methods which represent program logic. When implementing an object-oriented design, the main objective is to translate objects' methods into programs, code modules, and determine what event or message will trigger the execution of each module. Programmers analyze sequence diagrams and state transition diagrams that show the events and messages that trigger changes in an event. For object-oriented cohesion and coupling, classes should be as loosely coupled, independent of other classes as possible. The object's method also should be loosely coupled and highly cohesive. Doing agile application development uses a highly iterative process. Development team is in constant communication with the primary user, shaping and forming the system to match specification. Agile development is aptly named because it is based on a quick and nimble development process that easily adapts to change. Agile development focuses on small teams, intense communication, and rapid development iterations. It also uses an extreme programming. Example, the first step in extreme programming process, like any other development, would be to define the system requirements. The customer begins by meeting with the programmers and providing user story. Short, simple requirement definition. Programmers review user story to determine the project requirements, priorities, and scope. User story do not deal with technical details and are so short that they are often written on index cards. Programming team regularly meet with the customer who tests prototype releases as they become available. Extreme programming uses parallel programming, where two programmers work on the same task on the same computer. One drives while the other navigates. The onlooker examines the code strategically to see the forest, while the driver is concerned with the individual trees immediately in front of him or her. Agile methodology is becoming a very popular for software projects. Supporters boast that it speeds up software development and delivers precisely what the customer wants, when the customer wants it, while fostering teamwork and empowering employees. Critics claim it lacks discipline and procedures, produces systems of questionable quality, and may not work as well for larger projects because of their complexity and the lack of focus on a well-defined end product. When coding, you have a programming environment. You have Visual Basic, Python, Ruby, and SQL are examples of commonly used program languages. Internet-based applications use HTML, XML, Java, and other web-centric languages. An integrated development environment makes it easier to program interactive software products by providing built-in tools and advanced features such as real-time error detection, syntax hints, highlighted code, class browsers, and version control. Generating code. An application generator, report writer, screen generator, and fourth generation languages exist. Each program must test it to make sure it functions correctly. Desk checking. Groups of 3 or 5 IT members participate in code review. Objective is to have a peer group identify errors, apply quality standards, and verify that the program meets the requirements of the system design specification. Unit testing is the testing of an individual program or module. The objective is to identify and eliminate execution errors that could cause the program to terminate abnormally, and logic errors that could have been missed during desk checking. Unit testing test data should contain both correct data and erroneous data, and should test all possible situations that could occur. Programs that interact with other programs and files are tested individually before they are integrated into a system. Someone other than the programmer who wrote the program usually curates the test data and reviews the results. Integration testing is testing two or more programs that depend on each other to make sure that the programs work together properly. System testing performs a final test of all programs. Verify that the system will handle valid and invalid data properly, ensures that the IT staff has the documentation and instructions needed to operate the system properly, and that backup and restart capabilities of the system are adequate. Demonstrate the users can interact with the system successfully. Verifies that all system components are integrated properly and that actual processing situations will be handled correctly. Confirms that information system can handle predicted volumes of data in a timely and efficient manner. With program documentation, it describes the input, outputs, and processing logic for all program modules. Process starts in the system analysis phase and continues during system implementation. System analysts prepare overall documentation such as process, description, and report layouts early in the SDLC. This documentation guides programmer who construct modules that are well supported by internal and external comments and descriptions that can be understood and maintained easily. System documentation describes the system function and how they are implemented. It includes data dictionary entries, data flow diagrams, object models, screen layouts, source documents, and the system's request that initiated the project. The operation documentation contains all the information needed for processing and distributing online and printed output. User documentation consists of instructions and information to users who will interact with the system and includes user manuals, help screens, and tutorials. With user documentation, it's a system overview that clearly describes all major system features, capabilities, limitations, description of the source document content, overall overview of the menu and data entry screen options, example of reports that produce regularly or available upon users' requests, security and audit trail information, explanation of responsibility for specific input, output, or processing requirement, procedures for requesting changes and reporting problems, examples of exceptions and error situations, frequently asked questions, explanation of how to get help, and procedures for updating the user manual. This just shows you an example of a page from a user manual. The instructions explain how to add a new task to the system. After system testing is complete, you present the results to management. You should describe the test results, update the status of all required documentation, and summarize input from the user who participated in system testing. You also must provide detailed time schedules, cost estimate, and staffing requirements for making the system fully operational. Prepare a separate operational and test environment. Provide training for users, managers, and IT staff. Perform data conversion and system cutover. Carry out a post-implementation evaluation of the system and present a final report to management. The environment for actual system operation is called operational environment or production environment. The environment that analysts and programmers use to develop and maintain programs is called the test environment. A separate test environment is necessary to maintain system security and integrity and protect the operational environment. A training plan is essential to provide the right training for the right people at the right time. The first step is to identify who should receive training and what training is needed. Look carefully at the organization and how the system will support business operations and who will be involved or affected. There's three types of training. Training that will be provided to the users, the managers, and the IT staff. Vendor training, if the system includes a purchase of software or hardware, then the vendor will supply the training. Many vendors offer web-based training options, including webinars and podcasts and tutorials. Webinars is an internet-based training session that provides an interactive experience. A pre-recorded webinar can be used and delivered as a webcast a one-way transmission whenever user wants support. Many training consultants, institutes, and firms are available that provide either standardized or customized training packages. IT staff and user departments often share responsibility for developing and conducting training. They train people in groups with separate training programs for distinct groups, select the most effective place to conduct the training, provide for learning by hearing, seeing, doing, and they rely on previous trainees. Interactive training. Most people prefer hands-on training. Its less expensive method can be used, including training manuals, printed handouts, and online materials. Also, online training, regardless of the instructional method, training plans should include step-by-step instruction for using the features of the information system. Training manuals should resemble actual screens, and tasks should be typical of the user's daily work. The more realistic, the better. You can always use video tutorials. The video learning sessions for this textbook were initially created for teaching tools. Later they were polished, edited, and transformed into streaming videos. The next thing you have to look at is data conversion. Data conversion security and controls maintains input controls during the conversion process. It ensures that all system controls measures are in place and operational to protect data from unauthorized access and to help prevent erroneous input. System changeover is the process of putting the new information system online and retiring the old system. Changeover can be rapid or slow depending on the method. There are 4 changeover methods: direct cutover, parallel, pilot, and phased. In direct cutover, it causes the changeover from the old system to the new system to occur immediately when the new system becomes operational. Usually, it's the least expensive changeover method because the IT group has to operate and maintain only one system at a time. For the parallel method, it requires that both the old and new system operate fully for a specified period. There are obvious advantages to parallel operation is low risk. The company can use the old system as backup, but it is the most costly changeover method. With pilot, it's implementing the complete new system at a selected location of the company. The old system continues to operate for the entire organization, including the pilot site. Restricting implementation to the pilot site reduces the risk of system failure. It's less expensive than the parallel operation for the entire company. With the phase operation, it implements the new system in stages or modules. It combines direct cutover and parallel operation to reduce cost and risk. Give a part of the system to all users, while the pilot operation provides the entire system, but to only some users. Risk of errors or failure is limited to the implemented module only. It's less expensive than the full parallel operation because you have to work with only one part of the system at a time.